This is Matd1544. We're busy with the differentiation and using the rules. And in the previous recording, we looked at the product rule and the quotient rule. And we saw that when we have a function and we want to find the derivative, we can't just do the distributive law. In other words, the derivative of f g prime is not f prime g prime. We said it here. It's not the same. So the same for the quotient rule. If we have a function f over g, we want to get the derivative. We can't say it's the derivative of f over the derivative of g. There's a rule. And then we realize that the product rule is the derivative of the first function times the second as it is, plus the other way around. When we get to the quotient rule, it's the derivative of the top times the bottom as it is, but then a minus, not a plus. So it's the same as the product rule at the top, just for the difference that we have plus in the product rule and minus in the quotient rule. So f prime g minus f g prime, and then divided by the derivative squared. Right, so now we can handle complex equations, and we've done a couple of examples. But this morning we want to look at what we call the chain rule. Now that chain does mean the same as the chain reaction, so that is where the word comes from. And I personally think this is maybe the most important rule we do in our course, because if you cannot do the chain rule, there's very little that we can do in calculus. So we really need to understand this rule properly and to apply it properly, because this is really a huge rule for us in our course. Okay, so the chain rule has to do with a function of a function, which we have done last semester. We have done functions of functions, f circle g, g circle f, all those things that we have done. So when we try to do the derivative then of a function, we will find the derivative of the outside function, keep the inside function as it is, and then times it by the derivative of the outside function. Okay, so say now we have 2x plus 1 squared. Let's say this is now our big function f, capital, like in the notation here. Okay, then it means that this little 2x plus 1 is actually now the g that was put into the old f. Okay, so if I've tried to find the derivative, sorry, that's just now the function, that should not be there yet. It's just now like f. Okay, where the substitution already were done. So in other words, we had f and we had g. So most probably f was, say, g squared, x squared, and g was now this 2x plus 1. And then f is now f circle g. F is f circle g, meaning we put g into f. If we put g into f, we find this equation. Okay, so we clearly have a function inside another function. So when we want to find the derivative now, then we do the outside function first. In other words, we do this function first. So that's going to just be 2 times x to the 1. But remember, now we have a bracket where g is already in here. So we keep the g as it is. So in other words, we're going to do 2 times, keep now g as it is to the power of 1. So that is just 2x plus 1. So we do the outside function first, which is the power. the square there. So we know that if we want to do the power, we do 2 times 1 and then 1 power less. So 2 times 1 gives 2, 1 power less. Don't mess with the inside function. Keep it exactly as it is. And now you do the derivative of the other function, of your g, which is 2x plus 1. So the derivative of that is just 2. Okay, and now we can just simplify. We can now say it's 4 times whatever and multiply everything out. This is now not so important to me at the very moment. I want you to understand the rule first. So in mathematics, when you say of, you're already talking about a function of a function. So in other words, what I'm trying to say is, if I just read this, I will say it's the square of, you see, it's the square of 2x plus 1. Okay, so that already shows you that you have a function of a function. So now we have the square root of, say, x squared plus 5. Okay, let's just now call this now normal, just f of f. Okay, so now we need to find the derivative of this now. Remember, we're not using first principles now, we're using these rules, and the rule we're doing now is the chain rule, where we do the function of the function of the function, okay, the chain reaction. Alright, so if I read this, just by reading it, I will say this is the square root of x squared plus 5, you see? And that already tells you it's a function of a function. Okay, so basically we will rewrite that we have done. Alright. I mean the steps of rewriting first. That's what I mean by we have done. Alright, so we do the rewrite first. Now, if I find the derivative now, I do the outside function first, which is the power. So this becomes a half. And then keep now the bracket as it is. Don't go in there. Don't mess in there. That should now be minus a half because it's 1 power less. So it's a half minus 1, which is minus a half. And now we're going to multiply this answer with the derivative of the inside function, which is 2x. Okay, so this is how the chain rule works. It's not so difficult, but it's vital for us to understand it. Okay, so in the notes, I'm also showing you here the inside function and the outside function, and that we do the outside first, so the outside, and then multiply with the derivative of the inside. It's explained here also. So it's important that we look at that. Now, it's also important for us to be able to do the trigonometry here. So sine and cos. And in the book, write it. I'm going to see if I can quickly show it to you here. If I don't find it now, it's not a problem. We will look next time at it. But I'm just going to scroll down very quickly. And then just want to show you that at the bottom here, there it is. I have given you a table, and we will put this for you like, I mean, if it's an exam or big test again, we will give you this as on a formula sheet, sort of. So, but I think for next year, your people will have to know this, but for this course, we will give you this little thing on a formula sheet, this little table. So you people must know that the derivative of sine is cos, and the derivative of cos is negative sine, and the derivative of tan is sec squared, and the derivative of cosec is minus cosec cot. The derivative of sec is sec tan. The derivative of cot is minus cosec squared. Very interesting, the derivative of e remains e. And the derivative of ln is 1 over x. At the end of last semester, we did the e and the ln function. So, very important function. So, the derivative of e is e, and the derivative of ln 1 over x. So, you need to know this, or to be able to use this. Okay, so if I can scroll back now to where we were, just quickly. Just go back to where we were. Okay, just go too far. Okay, almost there. But we can just carry on there. Here we are busy with the chain rule. Okay, if we go to here, and now we see we have something like the function f is the sine of 3x squared plus x. Now once again, remember we're working in radians here. And please keep that in mind, don't go to degrees. Okay, so if I need to find the derivative here, the outside function is sine, because it's the sine of. Okay, the sine of. So, we will first do the sine. Well, that is the cos. So, that will be cos. Now, when you do the outside function, don't mess with the inside function. So, that will remain exactly the same. 3x squared plus x. So, we just did the sine now. Now, we go to the inside. And we say, okay, I must multiply this now with the derivative of the inside function, which will then be 6x plus 1. So this is going to be times 6x plus 1. And please put brackets here, because it's the whole thing times the cos, not just the 6x. So be very, very careful there. Okay, so I'm sure you will find the answer here the same. Okay, so it's the cos, keep the inside as it is, times the derivative of the inside, and then we can just simplify. Okay, so let us look at the next one here. So what do we have here? We've got a power and then an inside. So if I do the derivative, I'm going to do the power first. So that's going to give me 50 times the brackets as it is. Don't mess there. You leave it intact. It stays as it is, because that's the inside function. We find the derivative of the inside function after we've done the outside function first. So this will be 49 now. 1 power less, because this is the power rule. 50, there's a 1 in front. So 50 times 1 is 50. The brackets to the 49. Now times the derivative of the inside function. Well, that little piece there is going to be 6t squared. So that's going to be 6t squared plus, now the derivative of cos on that table you'll see is minus sine. So this is going to be minus sine t. Okay, and then we can just simplify the rest of it. Okay, so if we go scroll down where the answer was done here, so there we see the same thing, 50, 49, and then the inside, and then of course we can just simplify further. Right, so the last example that we have here, so now we have e to the whatever. Well, the derivative of e stays e. So in other words, if I do the outside function, which is e, remember it's e to the power of. So remember that w squared is not the outside function. No, that's the inside. Because if you read that, you will read e to the power of. Okay, so e is the function you're going to do first, and then after the of, that's what you're going to do next. So it's e to the power of, so we do the e first. When we do e first, the derivative of e stays e. So that will just stay exactly like it is. The derivative of e stays e. Right? Now times the derivative of the outside of the inside function, so it's e to the power of. Well, now you're going to do the derivative that you will say of to the of. So it's e to the power of w to the 4. Okay, so that's going to be in brackets again, because it's the whole thing times the whole thing. So it's 4w3 minus 6w. And then, of course, the 9 is going to fall away because that is a constant. So that will be the derivative of number C. We can scroll down here and just check, and you will see that it is the same that we got there. Okay, now if we look at ln, well, the derivative of ln is 1 over. So if I want to find the derivative here, it's the ln of. So ln is the outside because it's the ln of. So I'm going to first do the ln. That is 1 over. So 1 over everything I have. Now times by the derivative of the inside function, which will now be minus 4x, and remember 1 power less, minus 5, plus the derivative of the x4 is 4x to the 3. So that's how we will do the chain rule there. Okay, and then we can simplify it, and yeah, if it's possible. Okay, taking out x common factors and things like that. But remember now, you must read your question properly. Sometimes we will tell you you do not need to simplify. Then you will just stop there. Because actually in this course, we just want to see, can you use the chain rule? We're not so, the further simplification is not what it's all about for us at this point. But remember, when you go on with your mathematics and so on, and you will have to be able to simplify. It's just that the simplification just doesn't fall under this course. I mean, that was done earlier. To simplify is part of our maths throughout school and whatever. It is part of that. It's not for us the most important thing now. The most important thing for us now is, can you use the chain rule? So okay, if we can just look at say now sec of, again it's the sec of, so sec is the outside function and 1 minus 5x is the inside function because it's the sec of 1 minus 5x. So the derivative of sec is sec tan. So we're going to have sec of the brackets, tan of the brackets. Don't mess now with that brackets. Remember, the derivative of sec is sec tan. So you're going to use sec with the brackets as it is intact, and then tan with the brackets as it is, because the sec tan forms the derivative of sec. So for both those two brackets, you're not going to mess there. So it's going to stay 1 minus 5x here, and it's going to stay 1 minus 5x there. And now you're going to find the derivative of the inside function. The inside function is 1 minus 5x. So now we're going to find the derivative of the 1 minus 5x, which is negative 5. And then, if it's possible, we will simplify more. But again, for us, that first step is the important thing. Can you apply the chain rule? Okay, so let us just look. Say now we have, let's just make it complicated now. Let's say we have the sine of the square root of the cos of 2x. Okay, so listen now, if we talk about this function now, what do we say? We say it is the sine of the square root of the cos of 2x. You see how many functions you have there now? You've got sine. Sorry, I want another color. We have the sine. We have the square root. We have the cos. And we have the 2x. There's 4 functions involved here. So that's the chain reaction. So when we do the derivative here, we need to go through all 4 of those functions. Okay, so if I need to do the derivative here, I'm first going to rewrite. So I'm just going to write it as sine and then cos 2x to the half. Okay, remove the square root there. Now we can go to the prime. F prime. So first the sine. Well, the derivative of sine is cos. So this is cos. Now leave that as it is. So you can even write the square root if you like. In other words, you can now write here the square root of cos 2x. Or you can write the brackets to the half if you want to here. That doesn't matter. Now we go in. So now I'm going to do the cos because it's the cos of 2x. It's not the 2x of cos. It's the cos, it's first the square root now. So first the power half. Okay, so it's half brackets to the minus a half. That's what the power is going to give me because that was the second function. The second function is the square root. Okay, so it's half. Now again, leave the inside as it is. Times. Now we've done 2 of the 4. Now it is what I was trying to say. Now it's the cos of 2x. So I need to do the cos first now. Well, the derivative of cos is minus sine. Let's keep this in brackets. And remember the 2x must remain the 2x now because I'm not busy with the 2x now. I'm busy with the cos. I'm busy with number 3, which is the cos. Now I get to the 2x only, and that's going to be times 2. I think if you understand this example, you're 100% fine, because then you understand how the chain rule is operating through the derivatives here. And I think you can also imagine if you need to do this with first principles. This is to try to do this now with first principles. Now, f of x plus h minus f of x over h, the limit where h approaches 0. But that is exactly what we are still doing here. So these rules is just helping us making this now a lot easier. So once again, I'm saying if you understand how this one is working, I think you're 100% fine. So this is how we apply the chain rule for finding then the derivative in our course now.